Okay, we're on the last section of this unit, and it really has nothing to do with transformations, okay? So Unit 13, Lesson 6 is all about triangle congruence. Basically, we want to prove that two triangles are congruent using mathematical theorems and ideas, not just like, oh, they look the same size, so they must be, okay? So sometimes they do look like they might be the same, but if you don't have a mathematical reason, you cannot say that they are congruent, okay? So like one triangle might be 9.9 inches long and the other one is 9.995. All right, so there are specific strategies that we will be using and they're pretty easy to remember as well. So sometimes there will be a picture and information is not labeled, but using your math knowledge, you can add those labels in yourself. So there's two strategies that are used the most. So number one is vertical angles. It's probably been a while since you've done vertical angles, so let me show you how those relate to triangles and review that concept with you. So vertical angles are basically when you had an X, they were the angles that were across from each other. And we learned that vertical angles had the same size back when you did like corresponding alternate interior angles like that, okay? So what you're going to see is you're going to see two triangles that are joined together. And what happens is there's three angles in each of these triangles. And so we want to find the vertical angles. So the vertical angles are be the ones that are touching and they're right across from each other. So if you have a diagram like this and it's not labeled, you can go ahead and insert. That's the symbol, meaning that they're the same size, okay? That they're equal, because I labeled them with the same measurement symbol. The other thing is about sides. So this one is hidden, okay? And it's really referring to the same side. So typically what you'll see is, let's just draw a triangle up here and then a triangle down here. You'll see two triangles that are joined together somehow. And they might have other things labeled, but there'll be nothing labeled here. So if I look at I'm just making up letters. So if I look at segment BC, which is right here in the middle, that's on the top triangle. And then BC is also a side in the bottom triangle. So that's what I mean by the same side. It's one side in two different triangles. So we know that those are the same size as each other. So usually you just label them with the same symbol, like a slash. So I might just draw two slashes, and that means that that's the same size. Okay, so once again, if you see joined triangles, you can insert that equal symbol. Okay, it could be one slash, two slash. You can draw a triangle, a heart, whatever shape you want to indicate. Okay, so for angles, we usually do a little arc, and for sides, we do little slashes to show congruent. Okay, so there are 5 theorems that are allowed to say that two triangles are congruent to each other. All right, and when you name your triangle, the order will be important. So I'm just going to draw these disjoined. Okay, so I'll say A, B, and C, and let's do D, E, and F, okay? And they're going to try to orient these all different to try to trick you and see if you really know if they're congruent or not. So the first way is called angle, angle, side, okay? So it's AAS, and you want to use it in that order. So what that means is you're going to know that one angle is congruent to another angle. In the same order, we're going to go to a different angle. So I'll use B, is congruent to E, and notice how they have the same symbol, so I know that those two are congruent to each other. And then we need the side that's next. So if I went angle, angle, the side that's next is right here. Okay, we don't jump to the next side. So that's what I mean by the order. And so if I had this labeled, I would do, oh, angle, angle, side. We don't do side, angle, angle. Okay? And so you just see it, they're congruent by angle, angle, side, and you would say triangle, let's say A, B, C is congruent to triangle. Well, A is in the same spot as D, B is in the same spot as E, and F. So that's what I mean by the order is important. Okay? So same idea. Let's do side, angle, side. And I'm just going to flip these, let's say. So let's do C, D, E, F, G, H. So it has to go in this order, side, an angle, and then a side. So I'm going to pick, here's a side. I need an angle. I'm just going to pick the one on the left. And so this one would be the one on the right. And then I need the side that's next. So side, angle, side. Side, angle, and it would have to be that side. But see how they're in order of how they're drawn. Even though one is backwards, it's okay. They're still side, angle, side, side, angle, side. So we could say that CED is congruent to HFG by side, angle, side. All right, let's do this one. A, B, C, D, E, F. This is the easiest one to spot. So we've got our side would be congruent. We would have another side that was labeled congruent and a third side. So all three sides of the triangle would be marked congruent. So I'm going to say triangle, and I'll just start here. So D, A, oops, sorry. Let's make that D, F, E since I went backwards. Okay. And so I got to find what's corresponding. So D to F was the 3, and then we went to the 2. So I need to go from the 3 to the 2. So I would say A, D, C. Okay. All right. Angle, side, angle. We're just going to get a little different because all your pictures can be different. So I would have an angle, a side, and then an angle. An angle, a side, and then an angle. Okay. And then HL stands for hypotenuse, leg. So you do need a right triangle only, because only right triangles have a hypotenuse. Remember, the hypotenuse, if you have a right triangle, is across from the right angle. So I would have 2 right angles, and it should be labeled as right. You shouldn't just assume that it's right based on how it's drawn. And I would know that the hypotenuse is the same, and I would know that one of the legs is the same. And then you can say those 2 triangles are the same. So you only need 2 things, and everything else you need 3 items of information. All right, so let's look at example 1. So once again, go up above and see if you have any of these conditions. I don't have angles across, but I do have a joined side. So you're going to go ahead and add that in. 1 slash and 2 slash were already taken, so I picked 3. Okay? So now I've got a side, and a side. And they're all marked. So I would say, yes, they are congruent by side, side, side. There's really not a lot of work to show. On here, since this is a line and I know that that's a right angle, then I've got these share a side, so I can mark that. But what I don't know is the hypotenuse. So it is possible. We don't want to assume, but I would say no. There is not enough information. Okay, we don't have the hypotenuse, but we do have 2 legs. All right. And example 3, I've got a side, I've got a side, and this looks like our vertical angle situation. So I can label that. And so I look at the order. I've got an angle and an angle. So I've got side, then an angle, and then a side. Side, angle, side. So yep. Okay. All right, so let's look at example 4. So 2 more. So it says state the additional information that's needed, and there might be more than one answer depending on the diagram given. So they want to use side, angle, side, and let's look at what we have. We have a side and we have an angle. And so I need the next side because it's side, angle, side, side, angle, side. So what I would need is that DA is congruent to TO. All right? And there's no other option on this picture. The last one says we want side, angle, side. So here's side and side. And so I need the angle in between those 2 sides. So side, angle, side, side, angle, side. So I would need to know that angle C is congruent to angle J. And since they're not touching, I can use one letter to name those angles. Okay?